Hello, good morning. Welcome to the SWAM platform of learning. The course name of this lecture will be the power generation technologies. Under this power generation technologies, we are going to cover reheating and recycle in this presentation. I am Dr. Suraj Kumar Mukti, Associate Professor in the Department of Mechanical Engineering, National Institute of Technology, Raipur. The content of this presentation will be the introduction of the Rankine cycle and reheat cycle. And next we will enter into the principle of reheat Rankine cycle, working of reheat Rankine cycle, then we will see efficiencies of reheat cycle, then we will enter into the advantages of reheating, then we will see superheating of steam, then we will enter into the economizer, then we will see air preheater, then we will enter into the principle of regenerative Rankine cycle, working of regenerative Rankine cycle, then we will consider various kinds of advantages and disadvantages of regenerative Rankine cycle, then we will go for combination of reheat and regenerative Rankine cycle. So, this will be the content of this presentation. Now, the question arises, what is the purpose of reheating and regenerative cycle in any thermal power plant? The purpose of reheating and regenerative cycle in power plant is to improve the thermal efficiency and overall performance of the power generation processes. Reheating is a process where the temperature of the steam is raised after partial expansion in a turbine. The reheating processes increases turbine work, resulting in greater net work output for the power plant cycle. The purpose of reheating and regenerative cycle in power plant is to improve the efficiency of the power plant and overall performance of a power generation processes. Reheating is a process where the temperature of the steam is raised after partial expansion in a turbine. This is achieved without changing the compressor work or mass flow rate of steam. By reheating the steam, the average temperature of heat addition in the cycle is increased, which leads to more efficient energy conversion and improved overall thermal efficiency of the power plant. On the other hand, the regenerative cycle involves the extraction or bleeding of small quantities of steam at this extracted steam is then used to preheat the feed water before it enters the boiler or the combustion chamber. The heat energy from the high pressure steam is transferred to the compressed air, thereby increasing its temperature and reducing energy required to heat in the boiler. This regenerative feed heating helps increase the overall thermal efficiency of reducing the fuel consumption required for the same power output. In summary, we can say reheating and regenerative cycles play essential roles in power plants. Reheating processes increases the turbine work, while regenerative feed heating improves overall thermal efficiency by extracting heat from the exhaust gases and transferring it to the feed water. These processes contribute to the optimization of power plant performance and utilization of energy resources. Now, we will study one by one about the reheat cycle and regenerative cycle. About the reheat cycle, we discussed last topic thermodynamics cycle that converts heat into mechanical energy is known as a Rankine cycle. Rankine cycle has become a basic cycle widely used in modern thermal power plants. The conversion between thermal energy and mechanical energy can be realized through the thermal cycle of working medium in series of power plants. For the thermodynamic analysis of thermal cycle, mainly analyzes the thermal efficiency and steam consumption rate of the cycle to analyze the main factor affecting to the efficiency of the cycle and the measures to improve the thermal efficiency in order to reduce the fuel consumption and reduce the power generation cost. What is the principle of reheat cycle? Here we are going to explain about the principle of reheat cycle and reheat Rankine cycle. Principle of reheat Rankine cycle is explained here in this slide. The reheat cycle increases turbine work and consequently the net work of the cycle. This is accomplished not by changing the compressor work, the turbine inlet temperature, but instead by dividing the turbine expansion into two or more parts with constant pressure heating before each expansion. This cycle modification is known as reheating. By reasoning similar to the use of connection with intercooling, it can be seen that the thermal efficiency of a simple cycle is lowered by the addition of reheating, whereas the work output is increased. However, a combination of regenerator and reheater can increase the thermal efficiency of the power plant. Reheating is a method of improving Rankine cycle efficiency, which consists of inter-stage heating of the expanding steam. After the first stage of expansion, which typically reduces initial steam pressure by 1/4, the steam is heated up or close to the maximum heat source temperature. After the second expansion stage, the steam reaches consideration pressure. Although more heat into the required for heating, the efficiency of the reheating cycle is higher because the two stage turbine develops relatively more work. Double reheating cycle do exist and have been used in conventional power generation plants since 1950s. With respect to the basic Rankine cycle, the efficiency improvement of using a single reheat is on the order of 5% and using double reheat is 8%. Hence, using more than 2 reheat stages does not appear economically suitable for conventional power generation system. The use of reheat cycle is also justified in practical application. The maximum temperature of the cycle is considered for one of two reasons. Number 1, the nature of heat resource limit the temperature at which heat is available, that is geothermal heat, waste heat recovered, concentration solar receiver with associated temperature of 200 to 800 degrees centigrade, or second one, the safety and material resistance issue, which limit boiler temperature to the maximum of 800 degrees centigrade for conventional fossil fuels based power generation plants and 350 degrees centigrade for non-conventional nuclear power plants. Reheat means to heat something again or to make something hot or warm once more. So, the reheat cycle is the cycle of conversion of the heat energy to work power by increase the work turbine in a cycle. Increasing boiler pressure increases the thermal efficiency and thus excessive moisture in the low pressure stages of the turbine is avoided. There are two turbines working in this series. So, here in this slide we are able to see the reheat cycle, a schematic diagram of a reheat cycle where we can see the basic components of Rankine cycle, that is boiler, low pressure turbine and high pressure turbine, and another equipment is heater. So, basic components are already existing here like condenser, pump, boiler and turbine, but here in the case of reheat Rankine cycle we are using two turbines simultaneously. So, here in this case we are expanding the steam, high pressure and high temperature steam in turbine number 1. Then after reheating of the same steam we are entering the same into the second turbine, that is called as T2, and ultimately we are getting the work done by two turbines T1 and T2. So, eventually we can say the work done by this reheating system will get more work done using this mechanism. Here in this slide we can see the TS diagram of the same and HS diagram of the same, where we can see the turbine work is shown here in from 1 to 2 is the turbine work, and 2 to 3 shows the reheating of the steam. So, the steam is reheated up to maximum level again, and again it is passed through the turbine number 2, so that we can get another work in WT, I mean turbine number 2. So, again we can get the turbine work from 3 to 4. So, ultimately we are getting total network will be network done in turbine number 1 and network done in turbine number 2. So, exactly we can say the turbine work has been increased using the reheat cycle here. As shown in this figure, steam after expanding at high pressure turbine from 1 to 2 is extracted and further heat is added to it at the boiler. This is presented by 3 to 4. This reheated steam enters the low pressure turbine, further gets expanded till the condenser pressure is achieved. This pressure is represented by 4 to 5. Here we can see the efficiency of reheat cycle, how the efficiency of reheat cycle can be calculated here. Using this equation we can see the thermal efficiency with reheating, that is neglecting pump work here. Heat supplied is equal to H1 minus H4 plus H3 minus H2. Heat rejected will be H1 minus H4. So, work done by the turbine is heat supplied minus heat rejected. So, here heat supplied is H1 minus HF4 plus H3 minus H2 minus H1 minus HF4. So, ultimately it will be equal to H1 minus H2 plus H3 minus H4. Thus, theoretically thermal efficiency of reheat cycle is H1 minus H2 plus H3 minus H4 divided by H1 minus HF4 plus H3 minus H2, and thermal efficiency without reheating is H1 minus H7 divided by H1 minus HF4. Reheating is done at optimum pressure, and thus a large proportion of the heat supplied in the heating process will be thrown as a waste in the condenser. Now, we will discuss about the advantages and disadvantages of reheating cycle. Some advantages are considered as an increased output of the turbine can be get using reheating process. Erosion and corrosion in the turbine are avoided or minimized. Improvement of thermal efficiency of the turbine is done here in this case. Final dryness fraction of the steam is improved. Using reheat cycle increases the nozzle and blade efficiency, but some disadvantages of reheating cycle is also considered, like reheating requires more maintenance. When compared to the cost of reheating, the increase in thermal efficiency is negligible. Now, we will talk about the superheating of steam. The primary object of superheating of steam and supplying it to the prime movers is to avoid too much wetness and at the end of expansion. When steam engines are used with sufficient superheat, there will be more consideration in engine cylinder, and where steam is used in turbine, there will be excessive blade erosion wear. The maximum wetness in the final condition of the steam that may be tolerate without any appreciable harm to the turbine blade, about that will be about 12%. Broadly, each 1% of moisture is in steam reduces the efficiency of the part of the turbine in which wet steam passes by 1% to 1.5% in the engine about 2%. Here in this case we can see the picture of superheating of steam. So, here we are able to see the boiler and superheater is shown here. So, after superheating we can get steam in superheated condition. Now, the question arises, what are the advantages of superheated steam? Here we can consider some advantages of superheated steam. Superheating reduces the initial condensation losses in steam engine. Use of superheated steam results in improving the plant efficiency by effecting a saving in cost of fuel. This saving may be of the order of 6% to 7% due to first 38 degrees centigrade of superheat and 4 to 5% for next 38 degrees centigrade and so on. This saving results due to the fact that the heat content and consequently the capacity to do work in superheated steam is increased and quantity of steam required for a given output of power is reduced. Although additional heat has to be added in boiler, there is reduction in the work to be done by the feed pump, the condenser pump and other accessories due to reduction in quantity of steam used. It is estimated that the quantity of steam may be reduced by 10% to 15% for first 38 degrees centigrade of superheat and somewhat less for next 38 degrees centigrade of superheat in the case of condensing turbines. When a superheater is used in a boiler, it helps in reducing the stack temperature by extracting heat from the flue gases before these are passed out of the chimney. Here in this case we can see the function of economizer. What is economizer? An economizer is a device in which the waste heat of the flue gases is utilized for heating of the feed water. The picture shows the location, exact location of economizer, so that it can be utilize the heat of flue gases. Flue gases outcoming of the boiler carry lot of heat and economizer extract a part of this heat from the gases and set it for heating feed water. Economizers are of two types. Number one is independent type and number two is integral type of economizer. Some advantages are shown, like this use of economizer results in saving coal consumption and higher boiler efficiency. It reduces the temperature, which results in reduction of stresses due to the unequal expansion. Evaporative capacity of boiler is increased, overall efficiency of the plant is increased. Next component is called as air preheater. Air preheater is a device that increases the temperature of air before it is supplied to the furnace using heat from flue gases passing through the chimney. It is used to preheat the air before entering into the boiler furnace. The picture shows the clear cut direction of air flowing in the preheater. The function of air preheater is to increase the temperature of air before it enters the furnace. The preheating of air helps in the burning of fuel to a reheater extent. It takes the heat from the burnt gases from the furnace of the heat and air from the atmosphere. It is generally placed after economizer, so that the flue gases pass through the economizer and then to air preheater. Now, types of air preheater: number 1 plate type air preheater, number 2 tubular type air preheater and number 3 is regenerative type air preheater. The regenerative cycle water is before going to the boiler, the condensate, also known as feed water. After the boiler feed water, discharge is heated at various points to avoid irreversible mixing of cold condensate with hot boiler water, which causes loss of cycle efficiency. Various methods are adopted to do this reversible by interchange of heat within the system. thereby improving cycle thermal efficiency. This method is called regenerative feed heating and the cycle is called the regenerative cycle. Here in this picture we are able to see the working principle of regenerative Rankine cycle, where all the components are clearly visible like boiler, turbine and pump, condenser, and here we can see the bleeding steam and the two pumps are used here in this case. The same thing, the process is shown in TS diagram, that is 1 to 2, 2 to 3, 3 to 4 and 4 to 5, 5 to 6 and 6 to 7. So, this shows a complete cycle of regenerative Rankine cycle. In regenerative Rankine cycle, considerable amount of energy input is required at boiler to high pressure feed water from its normal temperature to the saturation temperature. To reduce this energy, the feed water is preheated before it is entered into the boiler. Preheating of feed water is done by regeneration method. The device in which water is heated is called as feed water heater. Some steam is extracted from various stages of the turbine and used to preheat the feed water. Regeneration is achieved by open or closed feed water heaters. In closed system, the blade steam from the turbine is not directly mixed with the feed water and therefore, the two steam can be at a different pressures. In practical steam power plants, various combination of open and closed feed water heater are used. Deaerator is an open heater and low pressure, high pressure heaters are closed feed water heaters. Some advantages and disadvantages of regenerative cycle is shown, like heating process in the boiler tends to become reversible, thermal stress set up in the boiler are minimized, thermal efficiency is improved using regenerative cycle. Using regenerative cycle, blade height is less due to reduced amount of steam passed, improvement in the turbine drainage and reduction of the corrosion due to moisture. A small size condenser is required in regenerative cycle. Some disadvantages are also shown here, like plant become more complicated using this regenerative cycle, greater maintenance is required, the heaters are expensive and the increase in thermal efficiency is negligible in relation to the higher investments. Now, we will discuss about the combined reheat and regenerative cycle. What will happen if I go for combination of reheat and regenerative Rankine cycle? In practice, the combination of reheat and regenerative Rankine cycle is used in thermal power plants. Single or double stage reheat along with the series of high pressure and low pressure feed water heaters are used in practical power plant. Rankine efficiency increases with the increase in steam pressure and temperature. A regenerative or reheat cycle is selected depending upon the capacity of the plant and other conditions. The combined reheat and regenerative cycle is shown here in this picture. In this picture, we are able to see the TS diagram of combination of reheat and regenerative cycle. The Rankine cycle performance and efficiency can be improved with the reheat cycle as well as by the regenerative cycle. It can be improved by increasing the thermodynamic properties of the steam entering into the turbine. At the initial stage, increased pressure results in an increased expansion ratio. Reheating and regeneration is used together because the intercooled and reheat cycle can each include regeneration to recover some of the exhaust heat to improve the thermal efficiency of the respective cycles, and indeed there will be a significant increase in thermal efficiency of these cycles. Now, concluding this lecture, we can say what are the main aim of reheating and regenerative cycle. When we are using the reheating and regenerative cycle in power plant, It improves the thermal efficiency and overall performance of power generation processes. Reheating is a process where the temperature of the steam is raised after partial expansion in the turbine. The reheating process increases the turbine work, resulting in greater network output for the power cycle. So, here we can say the application of reheating is for higher network output. This is achieved without changing the compressor work or the mass flow rate of the steam. So, here we can say the compressor work is kept constant during the reheating process, and the mass flow rate of the steam is also constant, though we are getting the higher net work done. By reheating the steam, the average temperature of heat condition in the cycle is increased, which leads to more efficiency energy conversion and improved overall thermal efficiency of the power plant. So, here we can say using reheating we are trying to increase the efficiency of the power plant, so that we can save the fuel or we can save energy, and ultimately we will get higher efficiency of the plant. On the other hand, we can say the generative cycle involves the extraction or bleeding of small quantities of steam at the intermediate stages of the turbine. So, here what we do is we bleed the steams in high temperature and we pass it using tubes, and we use this temperature to reheat the incoming water. The extracted steam is then used to preheat the feed water before it enters the boiler or the combustion chamber. The heat energy from the higher pressure steam is transferred to the compressed air, thereby increasing its temperature and reducing the energy required to heat is before the boiler. This regenerative feed heating helps increase the overall thermal efficiency by reducing the fuel consumption required for the same power output. So, ultimately here in this case we are trying to save the fuel consumption, and eventually the efficiency of the power plant will be increased. In summary, we can say reheating and regenerative cycle play an essential role in power plant or in modern power plant. Regenerative increases the turbine work, while regenerative feed heating improves the overall thermal efficiency by extracting heat from the exhaust gases and transferring it to the feed water. These processes contribute to the optimization of power plant performance and utilization of energy resources. In modern practices, what we do is the combination of reheat and regenerative Rankine cycle is used in thermal power plants. Single or double stage reheat along with the series of high pressure and low pressure feed water heaters are used in practical power plants. Rankine efficiency increases with the increase in steam pressure and temperature. A regenerative or reheat cycle is selected depending on the capacity of the plant and other conditions. So, there are various conditions on which there are various factors on which we can select whether the reheat cycle should be adopted or regenerative cycle should be adopted. The combination of reheat cycle and regenerative cycle is shown here in this picture. So, this picture shows the combination of reheat and regenerative cycle, which gives the high turbine work with low power consumption. So, ultimately we can get high turbine work, overall work will be higher using very low power or low energy. So, ultimately using combination of reheat cycle and regenerative cycle is very effective for modern power plant nowadays. Thank you.